if you have any and discussion or offline or whatever is most convenient for you. But so the common pitfalls of a CEMS RATA, tripwires, issues that can come up. We want to talk about those and ways to avoid them. Because I think one of the issues is that CEMS certifications, they're pretty common in and of it themselves. I mean, they're done every year. You know, most facilities have several sources that have CEMS on them. You have the quarterly audits. So I think that presents opportunity for complacency to move in, and people just, it's the same RATA this year, or the same type of source. So, and that can lead to a lot of these things falling through the cracks. But the implications are severe. I mean, if you fail your audit, I mean, your process may not be able to operate. You know, you may have to employ more expensive, you may have to call a stack testing firm in, such as ourselves, come in and bring a trailer on site and provide alternate monitoring. You might have to pay a lot more money for emission credits, you know, if you're a power station. So there's a lot riding on these things. Therefore, it's really vital to conduct pre-planning, you know, sweat the details on these things that we'll talk about to make sure that they go off without a hitch. So here's my agenda. We'll talk about kind of a higher level certification objectives, types of certification events, the performance specifications that govern these RATAs, some common pitfalls and failures, and then touch briefly on protocol and reporting requirements. So of course, the primary objective of a RATA, or a relative accuracy test audit, is to demonstrate its relative accuracy. And it's called relative accuracy because you're evaluating the performance of the CEMS relative to another system. You know, you're not, it's not being certified, you know, against a NIST traceable standard. You know, its accuracy is being demonstrated with respect to in most cases a reference method test that's defined by EPA. And once your CEMS is certified, it can be used to demonstrate compliance with emission limits. It can be used to report representative valid emissions data. It's credible evidence. It can be used in demonstrating the level of the source if there are any violations associated with it. I mean, the data is, once it passes its certification, it can be used as evidence in whatever legal action that you could be involved with. So it's important that these are done right. So RATAs aren't the only audit that's conducted. As you can see here, there's quite a few. Depending on whether it's an annual test, whether it's a quarterly audit. You have cylinder gas audits where you're not comparing the system's performance with respect to another analyzer. You're just injecting gases, Protocol 1 gas standards to the facility CEMS and evaluating its output. So it's a little different than a RATA. You have audits for opacity systems, response time checks, interference checks, and calibration error tests. We'll touch upon that a little later too, where you demonstrate the calibrations are within specifications over the course of several consecutive days. That's called a drift check. So fortunately, EPA has published what's called performance specifications, which dictate how these certification tests are to be performed and what criteria the facility CEMS is held to. So there's a number of them here with messy fonts that you can see. And there's a different performance specification for the various types of CEMS that you have on your stack. If you have a NOx CEMS, for instance, you are subject to performance specification 2. And these can be found in part 60, appendix B. You'll see all these performance specifications listed there. And like I said, they'll provide criteria for, they're all a little different, but in general, how to install your CEMS, where to install it, how to conduct your audits, and most importantly, the criteria that each have to meet both on an annual and on a quarterly basis. So let's talk about some common pitfalls. They kind of fall into these categories. Pre-planning that you fail to do. Surprisingly, electrical power availability, will come on site and the proper power won't be there. There'll be a hiccup with, the voltages or where you're going to park your trailer. There's a lot of things that can happen there that can really delay the start of a program. Setup problems on the stack. It may not be ready for you. It may have a platform that's not safe. It may have ports that aren't in the right place. All these things should be looked at ahead of time. And of course, site safety issues. We didn't realize there was a safety climb that you have to, with a harness that you had to use to get up to the platform. We didn't come prepared for that. I didn't realize the stack was under such positive pressure. Do you have your respirators with you? No, we don't. We didn't realize that was an issue. So those are things that have to be looked at as well. Then there's the actual stack gas data itself. What's its temperature? Is it hot? Is it extremely hot? Did you bring your high temperature sample probes? Did you bring your, are you prepared to handle that equipment as it's pulled out of the stack at extremely high temperatures? What's your flow rate? Did you come with the proper range of flow rate monitoring gauges? Your type of flow, the static pressure, is it under a lot of positive pressure? Is it under a lot of negative pressure? All the moisture content, all these things, you really should sit down with your test team and talk about them, make sure they're aware of them. Most likely, if it's a recurring RATA, these issues will have already been flushed out. But if there's been a change to the process or something's different this year, it's good to talk about that. Moisture too is important. That if the test team isn't aware of a real high moisture level in your stack, that can cause problems with their sampling equipment. All of our, we're prepared to handle, typical ranges of moisture, 5, 10, 20%. But if you get higher than that, we need to know, we need to come prepared to knock down that level of moisture. So it's important. Diluent concentrations. Are you correcting to an oxygen level, like a 15% oxygen level, but your O2 level is very high, maybe it's over 19%, making such a correction difficult to do mathematically. That sometimes happens. Does everyone understand what the target parameters are? A common one is permit limits. Let's see if this thing works. That's something that some of the relative accuracy specifications that I referred to earlier, there is, in some cases, a certain percentage of your permit limit that your error needs to be within. And if you don't understand what your permit limit is, or your test team isn't aware of your permit limit, or the fact that you can evaluate with respect to the permit limit, you could fail a RATA. And then this has happened to me where, I reminded a facility, hey, they called me up and said, we're failing our RATA. We're screwed. We're over the relative accuracy limit of PS2. And I looked at the data. I said, well, wait a minute, your permit limit is 50 ppm. You can be within 10% of that, so no, if you use that as your criteria, you're okay. So be sure you look at that. Any hazardous pollutants present that the team needs to be aware of. If you have positive pressure stacks and you have a real high level of acid gases or other toxins that need to be looked at. Talked a little bit about the power. How close is it? Where is it? What power is available? Do you have a sufficient amount of power? Is it the right phase? Is it single phase? Is it dual phase power? Is it 480, 240? Make sure that, in the pre-meeting, you talk with your contractor and say, okay, what does your trailer run on? Is it a 480, triple phase unit, or is it, simply a 110 source? and talk about, how is that going to be, tied in at your plant? I mean, do you have, do you want the test team to come out with their own plugs and tie into your 480 plug? Do we understand what those plugs are? There's a lot of different kinds. You come on site, we have our plug, and no, you still got to start messing with that. Do you want us to tie in directly to a welding outlet of some sort? Do you want to come into our trailer and have one of your electricians, take care of that? Those are all details that really should be handled ahead of time rather than on setup day. Can generators be used if there's not power at the site? Many of our trailers have onboard generators that we can use if there really isn't sufficient power available. We can always use that alternative source. And then you have the power to your CEMS trailer, but then you also need power on the stack where they're taking the samples from. There needs to be 110, 120 volt outlets up there as well for the equipment that's actually being used to take the sample in addition to where the trailer is. This seems pretty obvious, but if it's a new source, if it's something that maybe hasn't been, didn't need a CEMS before and one's been installed on, what's the orientation? How high are the ports? Like I mentioned, how do you get there? Ladders, scaffolding, or is it off a rooftop? Is it circular, rectangular? Its depth. That's something that the test team needs to know, so they can, again, make sure they bring what's needed to do the testing. And what is the flow profile? This is kind of an important one too, because if your flow looks like this, like say you have an axial fan down here. An axial fan is as the name implies, it's a fan that sits on a vertical axis that's parallel to the stack direction, and it just has a fan. And that creates a profile that you see here, which is totally unsuitable for volumetric flow rate measurements. It'd be very suitable for if you're just doing like a concentration type test, because it's going to be well mixed, that's for sure. But if you have to take a flow rate, say you have a pound per hour NOx reported unit that you're demonstrating compliance with, so you're taking volumetric flow checks in addition to the NOx concentration, this isn't going to work because it's just going to be too turbulent, and there's going to have to be a different situation for this type of emission point. Many times what will happen here is, if you're familiar with method 5D, there's specifications for flow straighteners that you can put in here. Typically, like stovepipes, like in a honeycomb type arrangement, you can install here to, and it does wonders for straightening out a flow profile like this. Just a matter of a foot long, 8-inch stovepipe arranged in a honeycomb installed in the stack will straighten all that out. But it's important to know that ahead of time, of course. How many ports are there? You need the 2 at 90 degrees, like what the reference methods call for. What are the diameters? If we have specifications that we have to have a certain diameter of a port to insert our sampling equipment, and if they're like little 1/2-inch holes, there's your ports. That's not going to work. We need at least a 2-inch. So now we got to put in ports, and so it's good to know what those are. Port collar lengths, height, where they are, and do they meet EPA Method 1 criteria, which is the method that dictates the acceptable location for test ports. If they're not located in an acceptable location, the test is not going to be valid. So you have to clarify that. Here's an example of a drawing that we'll frequently send to a client, and it kind of outlines what's the criteria for a platform, for the test ports, for minimum distances. It shows here like a monorail arrangement that's if you do have a long probe. In this case, they're doing other types of testing, probably not a CEMS RATA, so they have some sample boxes here, but even if you've got like a longer pedo, sometimes we'll put monorails up, and so you have to know, okay, how long is that going to be? What does this dimension have to be? So we'll kind of send this as like provides detail to you, on the test ports and diameters and such, to kind of walk through that specification process. So we talked about site safety. How do you get up to the platform? We thought about that. Ladders, stairs, elevators. Do we need to wear safety climb equipment? Is the platform OSHA certified? Does it meet the OSHA fall protection criteria with a mid top and a kickboard, toe rail? The railings are at the proper height. We've run into a lot of situations where the platforms were not safe, and we could not allow our folks up there because it just didn't meet criteria. So the facility had to make changes. But it's good to talk about that. If you're using man lifts, if you make sure that it's understood by all parties who's providing the man lift. Are the operators facility people? Are they going to be the test firm? Does the test firm have to be certified to operate the man lift? There's a lot of details that have to be flushed out there. Can the area below the location be secured? That's important because we always barricade off the base of the stack or the source. Despite doesn't matter how careful you are, if you drop something and someone's walking beneath your stack, that could be a serious issue. Something else that happens occasionally too is the handrails. And again, perhaps for a RATA, it's not as critical, but if they're too high in relation to the test port, see here, there you go. If this top railing is too high, the sampling equipment will not clear it. And the only option many times is just to cut the railing to allow that sample probe to slide in and out of the stack. And as you can imagine, that causes quite a buzz with the facility and with their safety people. And you want us to cut what? A safety railing? You're 100 feet in the air? No, we can't do. Well, maybe we can put a portable chain across. All sorts of things, to talk about there. So, again, I sound like a broken record, but pre-planning, to talk about it ahead of time. Positive pressure, safety, respiratory concerns, that's a big one, especially sometimes you're indoors. The ports are located inside in a mezzanine or wherever, and that especially is important, to make sure that if it is under positive pressure, what's the crew is being exposed to. Are we interfering with plant operations when we're doing our work? And of course, the weather. You're up on a stack. You got, especially this time of year, you got to watch the thunderstorms and stuff too. So common causes, and I've kind of ranked these in order, sort of most serious to maybe not so much, but this one's really important. And a lot of people don't do this, but you really shouldn't go into a RATA not knowing if you're going to pass. And that kind of sounds like, well, you're not cheating or anything. You just want to know that you're going to pass the RATA. So you're not going to all of a sudden on RATA day, the regulatory folks are there and okay, let's get started, and you take some data, and all of a sudden you're way out. You're not meeting your specifications, and it's like, stop the process. What's going on? And you got to dig into everyone's waiting around, and it's not the time to do that. What we recommend is prior to the start of the RATA, usually the previous day, take some data. Have your test team collect some data. Sync the times. Make sure that you got representative times, and just collect 10, 15, 30 minutes worth of data and then compare it. And then, wow, we're good. We can, and you're going to feel confident that you'll be able to pass your RATA the next day. And if there's issues, it gives you time to resolve them or postpone the RATA entirely if there's some serious issues that you have to resolve. So that's a big one. Also, especially if you've got a different kind of source. that maybe the sample location's a little bit compromised. You're kind of pushing the limits of method one. Maybe you're on a bend, close to a bend, and you've got stratification in the stack. You know, your NOx, and I'm speaking from stratification from a pollutant concentration standpoint. You know, your NOx concentrations will vary across the stack. So if that happens, you know, depending on where you're taking your sample from, like your facility CEMS probe is fixed, but the test team will be sampling at various points, and depending how stratified that stack is, you know, it can be critical as to where you're taking that sample from. So it's important to, again, early, you know, when they're taking some data on setup day, do a stratification check. It's part of the method. They have to do it anyway, but evaluate that data. And if it's showing extreme levels of stratification across, then take a look at that and make sure that when you're doing your preliminary checks, you're doing the stratification, you're sampling at the points that you will during the RATA. And then again, you'll know where you stand. Make sure that I mentioned that your DAS and your reference method times are correlated. That's something that you got to make sure you're comparing apples to apples, of course. I mean, if your test run is from 10 to 10:21, you want to make sure that all the clocks are synced up. And it's, you know, sometimes too, you got to watch that. A lot of systems, and it seems more so on the utility side, they don't correct for daylight savings time, so you got to kind of deal with that too. Incorrect calcs, rounding, not using the proper molecular weight. You know, sometimes that's something that catches folks on both the testing and the facility side. Make sure you understand, and that's been double checked. Something I haven't talked about are bias adjustment factors. And that applies to primarily to the utility industry, where the EPA and their infinite wisdom decided that, well, hey, you know, we don't like this possibility that a facility CEMS or power plant has a systemic bias to it that is resulting in them not paying their fair share of emission credits. So they came up with, when they wrote the Part 75 utility rule, the concept of a BAF, a bias adjustment factor. And that's something that if the facility CEMS is running lower than the reference method CEMS, well, that difference, in many cases, the EPA is going to want you to correct for through the use of a BAF. And there's calculations in Part 75, and you can dig into that if you want. But so that's another criteria in addition to the relative accuracy that we've been talking about. So you can meet your RA spec. You know, you've got that difference, but that's still within the relative accuracy criteria. But then you say, okay, we're good, right? But then you report to the client, oh, but by the way, you have a 2% BAF. And they're like, no, that's going to cost us $20,000 a month in emission. No, we can't have that. We got to do it again. We got to figure out how to get rid of that BAF, because that we cannot live with that extra. It's all about the money at that point. I mean, it costs, you know, because they have to. You take a 1.02 and you multiply that times your emission rate, and now, you know, your emission rate might have been 100 pounds an hour. Now you've got 102, and you know, with these utility plants, though, obviously it's a much larger number than that. So it really makes a big difference. So you don't want any surprises when it comes to that. Flue gas characteristics. You know, we have to operate our equipment at the required ranges that are specified in the test method. So, you know, we don't want to show up at a site not knowing, you know, that it's really a 2000 ppm SO2 level. We didn't come prepared for that, or if we have to require dilution, you know, that's something that could really catch you. I mentioned the moisture, also high particulate sources, you know, that can plug filters, you know, that should be addressed. Time. I'd like to try to pass this source. You know, you've got your reference method in blue, and you've got your facility CEMS doing this. You know, like I said, it's vital, especially if you have a situation like this, that you have these times nailed on both sides, because if you're off by even 30 seconds, and you end up missing a spike like this, so that you're not going to match up very well. So this is an example. This is a very challenging situation if you do have numbers that vary like this, to try to compare I'm just showing this to you to kind of, demonstrate that if you have just constant levels, which is typically the case on both sides, but sometimes you have a source that's, might be like a batch process, or might be some, type of temperature variance that causes a concentration to jump around like that. So that's a real challenging situation. So when you're doing a dilution CEMS, remember that is a wet measurement, even though you're diluting your stat gas to the point that your moisture is above the dew point. It's not going to condense out, but it's still considered wet. And you kind of surprisingly see this mistake made where you have a dilution system and they consider it a dry sample, and then they compare it dry to the reference method, which is dry. And then they realize, wait a minute, a diluted sample is wet. So now we got to correct for the moisture in the stack, and the moisture was 10%. So now we're 10%, and now we fail. So that's a gotcha sometimes. A cyclonic flow, we saw that profile that can really mess with you if you don't know it's cyclonic and you're doing a flow monitoring RATA, where our reference method has a pitot tube and your facility has a flow sensor, but the flow is all over and our measurements are just in error because the flow profile is bad. That's a problem, and again, to understand that ahead of time, you make sure your profiles are nice and straight. Interferences by other flue gases. Probably the most common example I can think of is maybe if we're doing a NOx RATA on a turbine exhaust and you have a high level of ammonia in your gas, you have a catalyst. That ammonia can bias our NOx numbers high because the ammonia is converted to NO that we're measuring in our NOx analyzer, and it'll cause a high bias. There are other examples too that make sure that you've looked at your flue gas composition, and that's not going to be an issue. If you have incorrect cal gases, that's something on the test team side, but sometimes we'll come to a site and we won't be really getting good correlation between the two systems, and it'll come down to just a bad cylinder, a bad mixture. Sometimes you get a protocol one gas, but it's just a bad cylinder, or someone logged in when they replaced the cylinder in the facility CEMS, they didn't properly document that, okay, I changed the cylinder and it's no longer 100 ppm, it's 108, but they didn't change it in the DAS, and so when it's doing its calculations, it's not recognizing. So that's something else we've seen. Improper calibrations, that can happen too, but not terribly often. And make sure that everything is corrected for, it's understood that, and primarily for flow RATAs, you may have to certify the unit of SCFH, standard cubic feet per hour. It might be a dry standard cubic feet per minute. It might be, just in standard conditions. It might, so, make sure that everyone has a clear idea that no, our flow rate is reported in SCFH, and make sure everyone understands, what that is. It's a wet number, but it's corrected to standard conditions so that, we don't, we're not going to dry it out and mess with the data. So DAS programs, problems, that's mostly timing. Make sure that your algorithms are correct. We've seen many times when, the facility is just not calculating emission rate correctly. It's not using the right constants. Double check that. Again, on a recurring RATA where nothing's changed, not an issue, but if you had a new DAS installed, might be a problem. Some other ones, This one here only applies to like a Part 75 type system where there is a number of certification checks that have to be passed before the system is fully certified. So it's just not your RATA, but you have to do a 7-day drift, you have to do a response time, you have to do a linearity check. All of those have to be conducted before you, quote unquote, pass your certification. This one is something we deal with a lot, and it's spelled out in the regs in some cases, and in some cases it's not. I mean, if you make a change to your CEMS, some people have seen this before. What does that mean? You know, does that mean you have to do another RATA? Does that mean you have to do a linearity check? Does that mean you have to do both? Does that mean you have to it really varies. You know, there are some regulations like Part 75 for the utility guys that have tables that say, okay, if you replace your heated sample line, that means you have to do X. If you replace your analyzer component, that means you have to do Y. But in a lot of regs, it's not spelled out at all. And that's where you have to get in your regulatory folks, your consultants, and talk with them and say, I just want to move my sample probe over to here because we want to install something over here. We just want to move it. Does that mean we have to do a RATA? I mean, again, you know, calling the guys back, that's expensive. But you don't want to just do it without thinking about it, because if someone comes by and says, well, wait, you know, you changed that. Did you do your certification? Well, no, we didn't think about that, so. Sure.
We're not necessarily a utility facility, but we're electric generating, so we have buy-in by Part 75.
They required you to be subject to that anyway, yeah.
Also have the Part 60 units. However, like you said, recertification is not spelled out in Part 60.
Right.
And so what we've done is internal PAs to demonstrate.
Yeah.
Again, it's not prescribed, so I'm not really sure. We, I guess, go by if it's legally defensible. That's what we say is our.
That's your policy, yeah. And that's probably fine. And, you know, a lot of times we'll get the state involved and say, hey, we just want to do a CGA when we make this change. Is that okay? You know, and some states are better than others. Some will, you know, have sharp guys on the sim side and be able to spell out exactly what they want you to do. Some won't. But yeah, it's good to conduct something to document it. Some people don't do anything. They'll just change. They'll change an analyzer out and they'll carry on like nothing happened. Not a good idea. So here's some citations for you. Some of what we've been talking about, where they are in Part 60, Appendix A and B and F, Part 75. You know, some of the timing. You know, the most initial RATAs are the first 180 days. Here's some other due dates, and this will vary by state, of course. You know, permits have their own standards. They have their own test plan requirements. It's very, very state specific, sometimes different regions within a state. So be sure and keep all of that in mind. So just some quick reporting kind of requirements to, you know, kind of reminders. Make sure that when you're reporting your data, you know, probably the biggest takeaway on this slide is to make sure you report to the state and the feds exactly what they require as far as demonstrating where you were at when you conducted your RATA. You know, many times, you know, you have to be over 50% of your capacity, you know, whatever that, you know, sometimes that's different to different people, what that means. But you want to be sure that in your report and in your test protocol as well, you define, okay, we're going to be, you know, producing so many pounds of our material during our RATA, or burning so much fuel, and make sure that data gets into your test report as well. So that's all I had. I think we have a few minutes for questions if anyone has any.